Profound means it's inestimable, estimate नहीं कर सकते. And the scope, the change that is expected. So when we are talking about Industry 4.0 or IIoT, the scale and scope of innovation of fourth industrial revolution defines the acute disruption and innovation. Few companies like Airbnb, it's a vacation rental marketplace. Uber, we all know, it offers vehicle on hire. Ola is also related to this. Then Alibaba, it's a Chinese e-commerce company. Similar companies are your Amazon and Flipkart. They all are the marketplace, and they all are disruptors of today. The players working in their area are facing huge problem because this issue, they are relatively new. Next is like iPhone launched in 2007. Ubiquitous means the handheld machines that can compute, that can communicate. The pagers, mobiles, laptops, tablets, these are ubiquitous in nature. So this ubiquitous iPhone launched in 2007 that changed the market scenario. The billions of smartphones are being mass produced currently. Similarly, Google announced fully autonomous cars in the year 2010. After that, you saw the AI-based self-navigating cars are on the way. Though it is yet to be launched in India, but in foreign countries, it's already there. Now, when we are talking about this profound systematic change, not only the speed of profound change, but the scale of profound change is equally surprising. How speed the changes that you are felt, that is there, but with that, the scale is also changing. The volume that is changing. For explaining this, one example I quoted, in 1990s, the industry giants in Detroit, it's a city of America, had a combined market of $36 billion capitalization. Out of that, $250 billion revenues, and the employees were 1.2 million. Compared to this, in 2014 survey, the industry giants in Silicon Valley had a combined market of around 1.09 trillion. See the growth. The capitalization is huge jump, whereas the profit is, the revenues is similar. And if you compare with the employees is only 1.13 million. That means 1,37,000 employees compared to 1.2 million employees. So number of employees in the organization, they reduced due to this adoption of new technologies. In context of fourth industrial revolution, use of AI, the area of AI, we all know. The use of AI includes self-driving cars, virtual assessment, we already observing this, online exams, transitional softwares, discovery of new drugs by using different AI tools, prediction of cultural interest, For explaining this, one of the examples of AI is application of Siri. Siri is the application of Apple. It's one of the examples of strength of AI. It can search through your voice command. Now it is already there in almost all applications, all mobile phones. It's related to, parallel to this is Cortana of Windows. This is a AI application. Now, who all are the drivers or driving forces of Industry 4.0? The various aspects that drive the fourth industrial revolution are, we can classify into few of them are the mega trends, that is the current, and the tipping points or tipping points. The mega trends includes the physical, digital, biological. One by one we'll discuss. When we are talking about the physical mega trends, they drive the Industry 4.0. One of them is physical mega trend. We can talk about automotive or autonomous vehicles, that is driverless vehicles. The driverless vehicles like trucks for transportation, drones we already saw, aircrafts, boats. These are the few examples from different sources. Now, another driver is, when you're talking about physical mega trend, another driver is 3D printer. We already know, as the engineering background people, you already know what is 3D printing. It's manifesting physical objects based on digital specifications. The researcher and the people and the students of different colleges, they design many things by using these 3D printers for this pandemic. Like by using these, you can design different things like wind turbines, medical implants. They are the major applications of these 3D printer. Next is advanced robotics. This is a conventional. We already know the conventional robots, they were used in automotive plants for part picking and assembling. But recently, the robotics are used from precision agriculture to nursing. For agriculture, for planting the seeds and other agricultural applications, they are using robots in different foreign countries. Similarly, they are using robots for nursing and other surgery also. It's an advanced robotics. In physical megatrends, another research that helped, that is new materials. The researchers, they are working on this area for designing lighter materials, like in flights or different industries, you need different types of materials. So sometimes you need lighter material, sometimes you need very strong material, sometimes you need recyclable, sometimes you need some adaptable. So these new materials can be manufactured, designed by different researchers. One of the very good example is plastic. Nowadays, the plastic is recyclable. Other examples are thermoset and graphene. Now, industry different drivers after physical. Another driver of Industry 4.0 is your digital. When you are talking about digital part, digital drivers, first is Internet of Things. IoT we already discussed, or in coming slides we will discuss. It's a network of different things. And the application of IoT in industry includes RFID, radio frequency identification. Few examples like tracking of packet delivery. If you are delivering the packet in industry, they are using IoT applications to track what is the location of that truck, what is the status of that packet delivery. All these latest market trends are all the new companies, they are using this particular concept. Next is complex supply chain management. It's another application of IoT in industry. As I told you, IIoT is for not only for production but also for supply chain management. That is a big issue in most of the organizations. And another thing, monitoring systems. Nowadays, different sensor-based systems you can design to monitor. One two application I will show you in the coming slides. You can monitor different things, but through the sensors, whether the environment is okay or not. You can, if any problem is there, after sensing, you analyze the data and you can alert. You can send an alert message to the owners or the particular concerned persons. Next is digital Bitcoin. We already know Bitcoin is a digital currency, and blockchain. Blockchain is a securing banking and government transactions. For securing, they are using blockchain. These are the different drivers of Industry 4.0. And next is the Uber model of transportation. It's carpooling, Uber, Ola, we already know. The different drivers in the biological area, the different research is on in the area of genetic sequencing, DNA writing, recommender system. Example is IBM's Watson. It can give recommend for a particular thing. Then cell modification, genetic engineering. This is the example. Now, the tipping points. What is the future? No doubt, latest advancements, latest technologies, they are helping industry. But what is your expectation in the coming days? The tipping points represent the radical changes in that are required in near future. The probable tipping points in coming years, one is the clothes that we wear. They should be connected to the internet. Similarly, unlimited and free storage. Nowadays, when you go for a laptop, you ask, what is the storage capacity? The future expects we don't want to measure the space complexity. Only computation complexity is measured. As a computer science student or engineer, they know what is space complexity and this computational complexity. So the tipping point for space is unlimited and free storage. Next is 1 trillion sensors connected. आज की डेट में in today's date around 32 billion sensors were connected to internet, but we expect by 2025 it may grow and reach up to 1 trillion sensors due to this particular implementation of IoT and Industrial 4.0. Then robotic pharmacist. In coming days, the robots will guide, they will support in medical. Nowadays, also in some countries, they are implementing this. These are the. Now, this is all about Industry 4.0. Now, few issues related to Internet of Things. I will not cover much on it. Internet of Things, we all know it's different things connected through a particular network or backbone. That may be a fridge, that may be a bulb, that may be a LCD bulb, or that may be a power point, that may be a AC, or that may be a cooler, or washing machine, or laptop, or mobile, or anything that is connected, and they can communicate and compute. That is the Internet of Things, this environment. We can define like this: the Internet of Things is the network of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, network connectivity that enable these objects to collect and exchange. By using this IoT concept, me and our team, we are working in a small project. We received some grant from a AKTU. In that, what we are doing, trying to deal that will monitor the pollutant level of Ganga at Kannauj. And this kind of IoT setups can monitor the water current, water level, and quality of water. Quality of water means the water pH level, turbidity, water temperature, etc. at a particular period of time on real time. That model you can design with different sensors. Few sensors are very costly, but according to your budget, you can identify many sensors. You can design an IoT environment. You can set up in the area of your interest, and you can collect the live data, store in the cloud, then analyze that data through a gateway. And after analysis, you can send the messages, alert messages, reports on a real-time basis. So this is what we are planning. So it's the simple environment for a IoT environment. Different sensors you can put here with the IoT nodes. Those IoT nodes will send the sensed data to the cloud. And from the cloud, it will go to a gateway through some software that you can use for converting data into your format and analyzing that data and concluding. And after that, you can send the alert messages and generate different reports on that. So this is IoT. The similar way, another case I would like to discuss, we are working on that, the radiation effect of plants. Due to different Wi-Fi and this towers, mobile towers, the radiations, it has been observed that the radiations that are affecting the plant growth. So that can be monitored and suggested to the government agencies the frequency signal level that should be allowable and allowed to the towers, so that it will not affect the plants. So this is one example. If we are planning to experiment on neem plants. So the plants can be equipped with some sensors. From that sensor, you can read what is this radiation level that is received by the plant. And it has been observed by different researchers that the plants, they are close to the tower, that is, they are close to the BTS, they are more affected than the plants, they are far from that. This type of applications can be designed, models can be designed, and reports can be generated and suggested to government agencies. This is all about IoT. And next is something I will discuss about industrial Internet of Things. Though during discussion of Industry 4.0, I already discussed about industrial Internet of Things in brief. Industrial Internet of Things can be considered as a branch of IoT only. IIoT is the application of IoT in manufacturing and other industrial processes with the aim to enhance the working condition, increase life, optimize operational efficiency. Previously, industries were used automation. Sometimes you may get confused with IIoT and automation. So the difference is that there are three key differences between IIoT and automation, which have been deployed in industries for decades. Automation, we just manage the things, control the things. But IIoT, through IIoT, what you can do ubiquitous sensing also. You can sense the different informations related to your organization, your industry, your machines, your things. And after sensing those data, you can analyze. That is called as advanced analytics. After analysis, you will came to a particular conclusion. What would be the problem area? What is the future trends? Using those analysis, you can take wise decisions. And IIoT includes few new IT tools and methodologies. That is the difference between automation and industrial IoT. Now, ubiquitous sensing. What is ubiquitous sensing here? In traditional automation, sensors, actuators are used to control critical elements, only control. But in IIoT, the sensors and actuators are used almost everywhere to control, enhance, optimize various functions. So the new things are you can enhance and optimize, not only control. By using sensing, not only you can able to control, but also you can enhance the things and optimize various functions. Similarly, we can another example is to monitor the machine health. In automobile industries, by using different readings, by sensing different things, they can monitor, they can tell you what is the type of repairing required for a particular car. Similarly, to track various operations in an organization, this IoT environment helps, and some emergency systems. This ubiquitous sensing enables advanced analytics also. The various data from array of deployed sensors and actuators can be exploited and extracted to decipher the latent meanings using varieties of advanced analytic tools and algorithms. In IIoT, the generated data is much more and varied compared to traditional automation. Because in IIoT, you are using so many other sensors and other things that generates different other informations that helps in analyzing and controlling. Whereas in automation, some limited sensors were used. In IIoT, advanced analytics helps to enhance the working condition, increase machine life, and optimize operational efficiency. IIoT modifies the traditional automation techniques by exploiting IT technology. This modification gives three main benefits. You will get the availability of talent pool, accessibility of available IT hardware and software solutions. Now, the different challenges that we face in this type of environments. The challenges in deployment of IoT are different, like data integration challenges, means how will you will integrate the data in an organization where you newly implemented this IIoT. For that, you have to plan for different hardware, software, and a trained persons for data integration. So that is the biggest challenge. Another thing is cyber security. How you will keep the organization's data secure. Then lack of standardization. Because it's a new IIoT is a new concept, there are no standards available. Then legacy installations. Legacy means the industry may have older computers, older hardwares. Those environments, those computational devices that will not support the new softwares and new platforms, means the compatibility issues might be there. That is all about legacy installations. Then lack of skills. The existing employers, they may not be able to adjust with the new environment, new technology. For that, what they need proper training at industry, particular of the first is data integration, lack of skilled workers, legacy installed base, lack of standardization, and at the top, the cyber security. In detail, if you discuss, first is data integration challenges. The main challenge is big data volume. As I told you, when I talking about IIoT environment, there may be a huge data generation. So the complex, when we are talking about big data, it includes 3 V's: variety, velocity, and the volume. Different variety of data might be there, huge volume of data is there. So these 3 V's are there: volume, variety, and other one I told. So there are huge amount of data you will face related to big data. The complex and different varieties of data from different sensors and actuators, the frequency of data generated by multiple devices. So the main challenge is managing those, and volume, variety, and velocity, speed of data. In this type of environment, data is generated very fast. So not only volume, but also the velocity is there. Speedily your data is generated. You have to store somewhere, you have to manage somewhere, and you have to plan accordingly. So that is the complexity of this particular thing, the complex and different varieties of data from different sensors and actuators. The frequency of data generated by multiple devices. Next is data integration is one of the main challenges. How we will integrate that data, that is again another challenge. And these type of platforms helps, different tools, they helps in data integration, and experts are required for that. So understanding the generated data for analysis and application in business is not an easy task. It's very difficult for a new organization. Next is Cyber security is one of the most essential. We already discussed about it. The elements of IIoT, because in IIoT, all the devices are interconnected, and these connected devices interact with the real world. Means that your industry data that may be used, accessed by somebody else, that is a challenge. So that is, for that, what you need, you have to use some different level of securities restrictions for your data. Without access permissions, they will not be able to access your data. Like in banking environments, you know, they are managing 3 different levels of security. One is 3D level of security, blah, 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 so many levels of security they are using. So in industry also, they may adopt any one of those security management techniques. The 2 most important security concerns of IIoT are information security and data privacy protection. So for example, when you are talking about healthcare industries, the details about a particular patient or the organization is very much important. If you are storing that information in a cloud, if somebody is accessing that data and opening that data in the market, then that will be a big issue for that. Similarly, food industry, they might have some confidential information, their production, different norms. If that is open in the market, then the industry may face big problems. Similarly, power grid, nowadays people are, you saw, they using the concept of smart grids. Smart grid means automated plants managed by different things, different sensor or IoT environments, or those smart grids. They also generate huge data. If the hackers, they're able to hack that data and the station, then your whole country or a particular city will be in problem. So at IIT Kanpur, one professor is working in the area of this smart grid security. They are putting different security levels in the power grids or smart grids, so that people or the hackers, they will not be able to hack that particular control. They can switch off the light of a particular city. So these are the big different challenges in these type of environments. Another thing is national transportation. Similarly, the national transportation data is also very much important. So if it is accessed by some unauthorized user, he may create problem. Then lack of standardization. The large automation suppliers firms do not encourage open standardization, as it will reduce the customers' reliance on them. Small automation supplier firms lacks the capability to incentivize this huge step. Lack of standardization leads to means, as I told you, this IIoT is a new concept. Different standards are not there. If people are not following some standardization, then some synchronization, some other issues will arise. So the lack of the standardization leads to different issues related to device interoperability, semantic interoperability, security and privacy. If, like the computer science students, they know when you are designing a network, computer network, you have to follow different standards. You have to follow the OSI model, that is the open system interconnection. So that is standardized by ISO. So if you are not using a standardized thing, then this compatibility problem might arise. So this lack of standardization leads to different issues. As we all know, the new concepts when enters into market like web technology. Initially, people used to design software application on the basis of principles of software designing. But when web technology introduced in the market, new approaches, new styles, new scope were there. So many problems they faced. You might have faced so many challenges in NIC site also during result declaration. Initially, during result declaration, if the server is having huge load, it may not be able to give you services. That is due to the designing problem or management problem, because the scope was not clear, because the concept was new. Web technology concept was new during that time. But slowly, the different standards were introduced in the market, and now things were working fine. The same way, if you are implementing a new environment in your organization, so this type of problems may arise. Legacy installations, as I told you, the old environments, existing environments may create problem. Technology evolves fast. Coexistence of the fast evolving technology with legacy equipment is a huge complication. Means if your organization is having old computational environment devices, if that is not supporting the new technology, that is the legacy issue. Then lack of skills, the limitation of workers with IIoT related skills like data integration, etc. That is an issue, because the technologies associated with IIoT are new. We know that the workers should have vast, diverse knowledge about it. This is another challenge. Now, the key application areas of IIoT. The key application areas of IIoT are healthcare industry, mining industry, manufacturing industry. As we already discussed, in manufacturing plants, we can implement IIoT, or we can follow the standards of Industry 4.0, technologies related to 4.0. Then transportation and logistics. In logistics, it has been used very popularly, this IIoT environments, because they are able to know through this particular environment what is the status of my parcel or packet, that packet delivery. Similarly, firefighting, so many new sensors were developed. One of the sensors, Ublu, by a team. They are working on that. Ublu sensor is able to identify the location of a firefighter in the disaster area. So that those type of application you can design. So in firefighting also, you can equip the firefighters with IoT devices that will track the location of the firefighters and other things to identify, to manage, so that they can resolve the problems easily. So there are so many other applications. We discussed few of them. The benefits of IIoT, that is definitely it improves the connectivity among devices. It improves operational efficiency. It improves productivity. It optimizes asset utilization. It creates new jobs and business opportunities. It reduces the operation time. With these words, I would like to conclude this IIoT has many promising features, but at the same time, it has many barriers. It does not mean its future is black, but it is better to deploy it in the areas where the hindrances are less. Thank you. These are the references.
Thank you. Thank you very much, sir. Your session was very much informative, and a lot of participants has also appreciated. And
Thank you,
I
sir.
can see
Thank you.
many of the before I open the session for questions. I would like to request you that many of the participants have asked for your PPT. So I
Acha.
would also
Sure,
request you kindly you.
I will definitely send to you, and you can share that PPT to your participants.
Okay, sir.
Definitely.
Okay, sir. So session is open for questions, and none of the participants have sent their questions in chat box. So I would like to request the participants to please unmute. Please raise your hand so that I should speak your name, and then you unmute your mic and ask the question. Please. Any of the participants, please ask the question.
Yes. Sir, good morning. Hello.
हाँ,
Yes, I am
सतीश
Yes,
बताइए.
please, you are audible.
Sir, actually, I want to know what kind of challenges we face if we want to implement Industry 4.0 existing industry,
Sorry, your voice is not clear.
or any industry in which we are at the 4.0 concept. Yes. Hello.
Your voice is not
Hello.
clear. Hello.
Hello, sir. Sir, I am
Okay.
audible. Yes.
You're audible now.
Sir, actually, I want to know what kind of challenges we face if you want to implement Industry 4.0 concept in existing industry.
Hello.
Yes,
Am I
sir.
audible? If I
Yes, sir.
understood your problem, you are asking if an industry wants to implement this Industry 4.0, then what would be the challenges? Hello?
Yes, yes, sir. Actually, your voice is breaking. Yeah.
The challenges I already discussed in my slides very clearly. When a industry trying to implement or trying to adopt the Industry 4.0,
Actually,
at that
sir,
time,
excuse me, sir. Actually, I want to know about any case study that any Indian industry have implemented a 4.0 concept and what kind of problems
almost all
challenges they.
simple like Flipkart. Flipkart is Indian company.
Okay.
Without that, how can that Industry 4.1? So many industries they are already adopted since last few years, and it is working successfully. But it's a big challenge for the new ones. Means those who haven't implemented that, and they are entering into that particular phase. That is a challenge for them.
Okay. Thank you, sir.
Okay, thank you.
Sir, one of the participant has asked a question. What is M2M here? Please explain again, sir.
Here, the M2M term is machine to machine, because in IoT environment, the things are connected. All things, they are having, if you take the example of this mouse, or you take the example of this glass, in an internet environment, everything is connected. And if you want to connect this glass to internet, you have to embed some electronics into it. And it should have some capability to communicate, compute, and control. So the things, they are having the capability of communication, controlling, and all these things, they can connect with that.
A few more questions are there. So I would like to read one by one. One of the participant has asked problem of internet connection in remote area. So how this can be while using IoT?
IoT is a technology that is related to that again depends on internet. Internet is different. World Wide Web is different. For implementation of IoT, you need internet. Internet is a connection of networks worldwide. That is a minimum requirement. So for implementing, for improving that in rural areas, what we need, we can suggest to the government, or the government will work on the area, so that basically electricity में rural में अभी तक it was not there, but now electricity is reached to all the remote places. So the same way, if internet is not available in some remote part of India, then government can work to develop or improve the infrastructure with the help of the ISPs or the major players like BSNL or Jio or Airtel, something like that.
Yes, sir. Yes, sir. Very informative and thorough answer. There is another question. One candidate has written, sir, please suggest the name of good sensors that can measure the arsenic content and iron content of water. I don't know if this come under IoT, but if come, please explain.
You can send me this question to my chart, so I can study this and I can let you know. Different sensors are there, but in particular, I can't remember that. For iron and this, it's related to chemical, so I don't have any idea at present. So we are also planning to purchase the sensors related to all this, but we are having few basic sensors only to work on to check the pollutant level.
Thank you, sir. No more questions are there, and I would request the participants that if I have some questions, so kindly directly connect to you and ask. So can we provide your email to participants?
I want to ask.
With your permission?
Sure.
Sir.
Okay. Thank you, sir.
Asking,
Thank you very much, sir.
Sir.
Sir,
I want to ask a question.
I think you have some announcement. So all the participants are requested to have an announcement from Dr. Harish sir, organizing secretary of the FDP. Please.
Sir, I want to ask a question. Hello.
Thank you, sir. Thank you, sir, and welcome all participants for for listening. Here is an announcement for today. There was a session scheduled from 12 to 1:30. At the 11th hour, AICT has informed for some mandatory lecture regarding stress management, which has been scheduled on last day. So content of this coming session, that is 12 today, has been merged on by same author on 8th October. So it means 12 to 1:30 session has been cancelled. Now we will gather again at 2:30 p.m. according to schedule. This was the information, and that was due to some limitation number of lectures which we have to keep fixed, and we have to add some stress management and yoga meditation session also. So thank you all for patiently listening. We
Sir,
will gather at 2:30
sir, एक
p.m.
question
today,
है.
and please try to join before 5 minutes. Thank you all.
Sir, I have a question, sir. Hello.
Sir, if any questions regarding the previous lecture by Patro
Yes, sir.
sir are there, email
Yes,
will
sir.
be shared to you, and
Okay,
you
sir.
may ask the question. You may share the question to sir directly.
Okay, sir. Okay, sir. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you so much.